What is the future of space? The future of space holds immense possibilities and continues to be a subject of great interest and exploration. Here are some key areas that are expected to shape the future of space. Space exploration. Human space exploration is likely to expand further, with plans for crewed missions to Mars gaining momentum. Establishing a sustained human presence on the Moon, developing lunar bases, and utilizing lunar resources could serve as stepping stones for deep space exploration. Private space companies are also playing a significant role in advancing space exploration initiatives. Space tourism. The concept of space tourism is becoming a reality. Private companies such as SpaceX, Blue Origin, and Virgin Galactic are actively working on spacecraft that will allow civilians to experience space travel. As technology advances and costs decrease, space tourism is expected to become more accessible to the general public. Satellite networks. The deployment of large constellations of satellites is increasing rapidly. Companies like SpaceX's Starlink and Amazon's Project Kuiper are aiming to provide global broadband internet coverage using thousands of satellites in low Earth orbit. These networks can enhance global connectivity and bridge the digital divide, but they also raise concerns about space debris and light pollution. Space mining and resource utilization. The extraction and utilization of resources from celestial bodies, such as the Moon and asteroids, hold potential for supporting space exploration and future industries. Mining operations could provide essential resources like water, metals, and rare elements for space missions and potentially fuel the development of space-based manufacturing and infrastructure. Space-based solar power. Harvesting solar energy in space and transmitting it back to Earth is an idea gaining traction. Space-based solar power could offer a continuous, abundant, and clean energy source, reducing dependence on finite resources and mitigating climate change. However, it poses significant technical and logistical challenges that need to be overcome. Space science and research. Advancements in space telescopes, observatories, and interplanetary missions enable us to unravel the mysteries of the universe, study distant planets, search for extraterrestrial life, and deepen our understanding of fundamental physics and cosmology. Future missions will likely focus on exploring other potentially habitable worlds and investigating the nature of dark matter and dark energy. Space debris mitigation. As the number of satellites and space activities increases, so does the amount of space debris. Addressing this issue is crucial to ensure the long-term sustainability of space activities. Strategies for debris mitigation, active debris removal, and responsible space practices are being developed to minimize the risk of collisions and protect valuable space assets. It's important to note that the future of space is dynamic and subject to technological advancements, policy decisions, and the collaborative efforts of governments, private entities, and international organizations. The potential for new discoveries and innovations in space is vast, and it will continue to inspire and push the boundaries of human knowledge and exploration. What will NASA do in the future? NASA has a broad range of plans and missions in the pipeline for the future. While specific details may evolve over time, here are some key areas of focus for NASA. Artemis program. NASA's Artemis program aims to return humans to the Moon by 2024 and establish a sustainable presence there. The program includes the Artemis I mission, an uncrewed test flight of the Space Launch System (SLS), and Orion spacecraft, followed by crewed missions, such as Artemis II, Artemis III, the Lunar Landing Mission, and beyond. Artemis seeks to explore and utilize the Moon as a stepping stone for future crewed missions to Mars. Mars exploration. NASA continues to prioritize the exploration of Mars. The Perseverance rover, which successfully landed on Mars in February 2021, is currently studying the planet's geology, searching for signs of past microbial life, and preparing for future sample return missions. NASA plans to launch the Mars Sample Return mission in collaboration with the European Space Agency, aiming to bring Martian rock samples back to Earth for detailed analysis. James Webb Space Telescope. The James Webb Space Telescope, JWST, set to launch in late 2021, is NASA's next flagship space observatory. JWST will provide unprecedented views of the universe, studying the formation of stars and galaxies, the atmospheres of exoplanets, and other astronomical phenomena. It is expected to revolutionize our understanding of the cosmos. Planetary missions. NASA will continue sending robotic missions to explore other planets and celestial bodies. For example, the Europa Clipper mission aims to study Jupiter's moon Europa, which has a subsurface ocean that could potentially harbor life. The Dragonfly mission will explore Saturn's moon Titan with a drone-like rotorcraft, investigating its organic chemistry and habitability. Earth science. NASA's Earth Science program focuses on studying our home planet and its complex systems. Missions like the Earth Observing System, EOS, satellites provide valuable data on climate change, weather patterns, natural disasters, and the overall health of the Earth's ecosystems. Future missions will contribute to a better understanding of Earth's dynamics and the impacts of human activities. Aeronautics research. NASA's aeronautics program aims to advance aviation technology and improve air transportation. Research includes developing greener and more efficient aircraft, exploring electric and autonomous flight, and enhancing air traffic management systems. International collaborations. NASA continues to collaborate with international partners on various missions. For instance, NASA and international space agencies are working together on the Lunar Gateway, a planned outpost in lunar orbit that will support lunar surface missions. Collaborations foster resource sharing, scientific discoveries, and the collective advancement of space exploration. It's important to note that NASA's future plans are subject to funding, technological advancements, and evolving priorities. As new challenges and opportunities emerge, NASA's focus and initiatives may adapt accordingly to address the needs of scientific exploration, human spaceflight, and the broader goals of space exploration. Space tourism. Space tourism refers to the concept of private individuals traveling to space for recreational purposes. It involves the transportation of non-astronaut civilians to experience the unique environment of space. While space tourism has been a topic of interest for many years, recent advancements in commercial spaceflight have made it a closer reality. Here are some key points about space tourism. Private space companies. Several private companies are leading the way in the development of space tourism. Companies such as SpaceX, Blue Origin, and Virgin Galactic have made significant progress in designing spacecraft and launch systems to transport tourists to space. Suborbital flights. The initial phase of space tourism is expected to focus on suborbital flights. These flights reach the edge of space, typically at an altitude of about 100 kilometers, 62 miles, above the Earth's surface. Passengers on suborbital flights experience a few minutes of weightlessness and get a stunning view of the Earth from space. Orbital space tourism. In the future, orbital space tourism may become more accessible. Companies like SpaceX have announced plans to offer orbital flights to civilians. These missions would involve spending several days or weeks in orbit around the Earth, allowing passengers to experience prolonged periods of weightlessness and witness breathtaking views of our planet. Space tourism infrastructure. Space tourism requires the development of necessary infrastructure, including spaceports for spacecraft launches, training facilities for passengers, and support systems for ensuring safety during spaceflights. Efforts are underway to establish spaceports and build the necessary infrastructure to support space tourism operations. Cost and accessibility. Initially, space tourism is likely to be expensive and accessible only to a privileged few. The early adopters of space tourism are expected to be wealthy individuals, celebrities, and adventurers willing to pay a significant amount for the experience. However, as technology advances and economies of scale come into play, the costs may decrease, making space tourism more accessible to a broader range of people. Safety considerations. Safety is a top priority in space tourism. Companies undertaking space tourism operations must ensure the safety of passengers during all phases of the mission, including launch, spaceflight, and re-entry. Extensive testing, rigorous training, and adherence to strict safety protocols are crucial for successful space tourism operations. Impact and regulation. Space tourism raises questions about its environmental impact, space debris, and potential conflicts with existing space activities. Regulatory bodies, such as the Federal Aviation Administration, FAA, in the United States, are working on establishing guidelines and regulations to govern commercial space tourism operations and ensure safety, environmental responsibility, and the sustainability of space activities. Space tourism represents an exciting frontier in human exploration and offers the opportunity for more people to experience the wonders of space. While it is still in its early stages, ongoing advancements in technology and growing private sector involvement suggest that space tourism will become more commonplace in the coming years, potentially revolutionizing the way we perceive and access space.
Subscribe for more horrors and mysterious videos. Thanks.